Hello, this is aMonkeyRC. You can see my desk is a little bit messy today because, as you know, I'm currently rebuilding my competition truck, and I just wanted to show how to build in a 550 sized Fusion Hobbywing motor into an SCX10.2 because it's really not that easy. Alright, so first a word for the transmission and motor. I'm using the metal case transmission here with a dick unit. You can also use the stock one that is made from plastic that comes with the creator kit. It is the same from the dimensions, and I was also surprised that it's actually not that much lighter than the metal cased one without the dick unit, so the dick unit adds some weight here, but overall it's not that much heavier. But it actually should work out also with the plastic one. For the motor I'm using the Hobbywing Fusion 1800 kV. That actually is an extra large can since it contains the ESC here in the end, and that makes things actually even more difficult, but we will see how we can do it. So that is how the internals are usually mounted. The motor faces forward, the spur gear faces backwards. And if you don't have a 4-link suspension, like I do have, 1, 2, 3, 4 links, you don't have an issue, since you're missing the 4th link and you will have a pen arm rod here in the front instead. Then you don't have an issue because the motor has nothing to block on, and it will just be above the left bottom link, which should clear fine. But if you want to have a 4-link suspension, which you need for an axle mounted servo, and you want to have high clearance links like I do, then you will get an issue. Okay, I hope that you can see it. The motor is now in its typical situation just above the rod end of the 4th link, and when I start to push down the whole vehicle, the whole suspension comes up. And that means that the link is pushing onto the motor from the bottom and pushes the whole motor mount up and puts a lot of stress on the whole mounting and skid plate. But you simply need 2 tricks to solve that. So step 1 is simply turn around your transmission. Of course you need to turn around your skid plate too. And simply put it into that configuration where you have your spur gear in front and your motor in the back. Then you need to configure your motor to have the other turning direction, but then you're fine. So there is no blocking of the 4th link anymore, and your back link is already much more in favor of supporting this. But still, it's still when you just push this down, just at the very end, it's the same situation. The link comes up again and it's starting to push up the motor. Okay, I was really tinkering a lot with the suspension. I shortened and lengthened the links. I was doing my own rod ends. I was creating my own links just to solve that. But then I came up with the most easy solution. And that is leaning forward your motor. It's really simple, just lean it forward a little bit so the motor end comes up and gives just enough clearance for the upper, right link. And how to do that? It's really simple. All you need is 4 of those shims here. So 2 I've already here on the transmission mounting hole, and I take the other 2 and put them on the other hole. So the back hole is a little bit higher than the front hole. As soon as you put the transmission on top and put the screws through from the bottom and pull them tight, it will automatically lean forward. Just to make sure that it actually works, you need to take a drill bit and drill out that hole a little bit, leaning to the left, so it will actually support a mounting position which is not absolutely vertical. And that's it. So that is how it looks like when it's finally installed. You can see how it leans forward and it clears all of the link below the motor. So that's just wonderful. This works out if you have just a typical crawler and you don't need anything super specific performant. But as soon as you want to have high clearance links specifically and some super large articulation, you will need a 3rd trick. Alright, so the first part is really check your suspension to work out really to the millimeter. So this is the rear link that I was using before. It's made of stainless steel and has quite a big high clearance bow in the front. So that works out perfectly for the clearing between the links, but it actually means that the whole mounting position comes up even more, and then it's impossible to find a way to make it work with that motor. So what I was doing is I was creating my own links from threaded rods, 4mm steel, rust free, and that works perfectly fine. I just made that bow really just enough to clear the lower link, and still it works perfectly in all situations with that motor. And the second part is you will get a nicer clearance here in the back, and also of course some weight distribution advantages if you can move your motor more to the front. And this is where this specific transmission comes into play. This is a step that won't work with the plastic one, since this has a hard attached motor mount and this one has a detachable motor mount. So what I did is I put some spaces, so these are the silver ones up here. These are 5 millimeters, and that's moving the whole motor just 5 millimeters more to the front. So that helps me clearing the rod end here perfectly and putting the whole motor weight even 5 millimeters more to the front. So this concludes my little video how to fit a large can motor with a Digstar transmission into an SCX10.2 performer rig with a 4-link front axle and some high clearance link. I hope you enjoyed the video, learned something from it. Keep it rolling, see you soon.